Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 11.1, Problem 5. This is Section 11.1, Problem number 5. It says, consider the function x squared minus x minus 20 over 2x minus 10, and then take the limit as the input value approaches a couple of different things, part A, B, C. So in part A, you want to take the limit of that function, x squared minus x minus 20 over 2x minus 10, as the input approaches 0. So again, you want to see what's happening, not in reality as you plug in a 0, but as you put in things super close to 0, like 0.001 or negative 0.001. Now, since I can actually put a 0 in this, and nothing bad will happen, like 0 at the denominator, what happens when I put in a 0 and when I put in things super close to 0, really the same thing. So I can just put in the 0 to see what happens as I put in things that are really close to 0. So on top, the x squared will run down to 0 squared. The minus x is minus 0. The minus 20 just stays minus 20. Like that. And in the denominator, 2x minus 10, it's really 2 times x minus 10, will become 2 times 0, the x is 0, minus 10. Now as I simplify that a little bit, the parts with the zeros I can just eliminate. Pay attention to the signs. I have negative 20. And in the bottom, the denominator, the part with the 0, again, I can just get rid of. And I'm off with minus 10. And the minuses will cancel, and 20 over 10 will reduce to 2. It reduces to positive 2. So as I put in values for input values that are super close to 0, the output gets super close to positive 2. And again, that positive 2 output is the height on the graph. You would be up 2 on the graph as you put in values really close to 0. Now, part B, I can't do that. I can't just put in the 5. It says find the limit as the input approaches 5 of the same function, x squared minus x minus 20 over 2x minus 10. So in part A, I was approaching 0. I just put in a 0 for x, and I was able to find the answer easily enough. Now for part B, if I try and put in a 5 for the x, because it says find the input as it approaches 5, find the limit as the input approaches 5, I get a 0 on the bottom. This 2x minus 10 becomes 10 minus 10. 0 on the bottom, can't do that, undefined. So I have to try and find a way to either put in something super close to 5 or actually put in a 5. So I want to try and factor something and cancel it. So I'm going to find the limit as the input approaches 5 of. Now the 2x minus 10 in the bottom, I'm going to start with that because it's simpler to factor. I can see that I can just pull out a 2. Both pieces have a 2, so I'll put a 2 in front of the parentheses. Now in the parentheses, 2 times x makes a 2x, and then for the minus 10, 2 times minus 5 would be minus 10. So I can factor the bottom that way. Now what I'd like to do is factor the top so that one of my parentheses will cancel. I want one of the parentheses to be an x minus 5. Now hopefully I can do that. So now if I put an x here, so I want to be able to FOIL it back and get x squared minus x minus 20. And it turns out that I can do that. And you can verify, you can FOIL this out, and sure enough you will get x squared minus x minus 20. But now that I have this problem factored, x minus 5 in the numerator and x minus 5 in the denominator can be canceled. And now I want to take the limit as x approaches 5 of x plus 4 over 2. Now I can just put in a 5 for x and see what happens. And again, I'm in reality not just putting in a 5. I'm putting in things that are very, very, very close to 5. But since I can put in a 5, what happens when I put in things very close to 5 and 5 are the same? So the x plus 4 on the top becomes 5 plus 4. And the denominator just has 2. So that's really 9 over 2, which doesn't really reduce. You can write it as 4.5 if you like, if you prefer that, or 9 over 2 is just as good. So as I put in values that are super close to 5, the output or answer I get is super close to 4.5. So I cannot actually put in a 5. But I can put in things as close as I want to 5, like 4.99999. the answer will come out very, very close to 4.5, or 4.5 if you prefer that. Now, part C, I have the same function. I want to take the limit of x squared minus x minus 20 over 2x minus 10 as the input approaches negative 5. Now, it turns out I don't have to factor this. I can actually put in a negative 5 for x. The bottom becomes negative 10 minus 10, or negative 20. So as long as it's not zeroing out the denominator, I can just see what happens when I take the limit by actually just putting in the value that I'm approaching. So just be careful with the negative. Take your time. So the x squared in the numerator becomes negative 5 squared, or second power. Minus x is minus minus 5. Again, be careful with your signs. Don't lose a minus. There's two minuses, one from the function and one from the fact that the value you're approaching is negative. So this is going to become an x plus 5, or at really 25 plus 5. Minus 20 on the end is just minus 20. And the denominator, 2x is 2 times x, so it's 2 times minus 5. And then you have a minus 10. So we'll simplify again. Be very careful with the signs. Don't lose a negative. Negative 5 second power is positive 25. The minus of minus 5 is plus 5. You have a minus 20. And in the denominator, 2 times negative 5 is negative 10. Then you have another minus 10. So on top, 25 plus 5 is 30. 30 minus 20 is positive 10. And in the denominator, 10 minus 10 is negative 20. Positive 10 over negative 20 is negative 1/2. So I am able to see what happens when I approach an input value of negative 5 by actually just putting in the negative 5. So as I always say, I'm not really putting in a negative 5 when I take the limit. I'm putting in things that are very, very close to it. And what I get as an answer becomes very close. The closer I get to negative 5 as an input, the closer my answer gets to negative 1/2, or negative 0.5 if you prefer decimals.